So again, going back to the previous reaction that I've drawn, so there was 2 molecules of the compound H2, dihydrogen, 1 molecule of the compound O2, that gives us 2 molecules of the 2 units of the compound water. If you look at it, you have 4 hydrogens on the left hand side, the compound H2 and 2 of them, that gives you 4 atoms of hydrogen, and you have 4 atoms of hydrogen on the right hand side. You have 2 hydrogens in the molecule of water and twice. And you have 2 atoms of oxygen on the left hand side, in the reagent side, and again you have 2 atoms of oxygen in the right hand side. And that's what we do when we balance chemical equations. We make sure that the total number of atoms that are in the reagent and the type of atoms you have in the reagents will appear in the products in a different combination, because that's what a chemical reaction is. When it takes place, you have certain reagents that become products, but the type of atoms you've got and the number you've got on each time does not change. When you're balancing a chemical equation, you can change the coefficients. Because you could have 1 molecule of H2 or 2 molecules of H2 or 3 molecules of H2, so you could have H2, or if you needed, you could have 2 H2, or you could have 3 H2. But the compound H2, that subscript, you cannot change, because that is the composition of the compound, is 2 hydrogens bonded together. You can have 1 unit or 2 or 3 or 20, but the compound is still H2. These 2 does not change. So when you're balancing a chemical equation, you never change the subscripts, because those are part of what the compound is. But you change the coefficient if you need to make sure that as many atoms and types of atoms you have on the reagent side appear in the product side. So we're going to be doing a bit of practice of balancing chemical equations, not because it's super important for you, but because it's a nice thing that before you use an equation for anything, a chemical equation, you make sure that it is actually balanced, because if not, whatever information you get from it will not be meaningful. And the general advice for balancing a chemical equation would be, first of all, work on 1 type of atoms at a time. It doesn't matter if you kind of almost spot how it's going to look like. Always make sure that you work on 1 atom at a time. And if there are atoms that are on their own, for example, here we've got 2 types of atoms that could be could consider to be on their own. The molecule O2, whatever number you put here, it will not affect the rest of the atoms. It would not mess with any balancing you would have done before. In this particular equation, you are quite lucky, because you have actually 2 atoms that are kind of on their own or reacting with themselves, the compound O2 and the compound H2. So you could leave either of them towards the end. So any atoms that are on their own or only attached to other atoms of the same type, leave them at the end, balance them last, because whatever coefficient you use that will not affect other atoms that you have already balanced. And at the end, just make sure that actually it is balanced. And it's very easy to find out if it's balanced, because if it's correctly balanced, you will have the same number of atoms and the same type of atoms on the reagent side than on the product side, just in a different combination. So I'm going to ask you to stop the video and have a go at balancing these chemical equations using the rules I've mentioned before. So please stop the video now. I hope you stopped the video and had a go at balancing these equations. So start with the first one. The first compound, CH4, is methane. So if I look at the carbon, for example, I can see that I have 1 carbon on the left-hand side in the compound methane and 1 carbon on the right-hand side in the product side, part of carbon dioxide, CO2. So this equation is balanced with respect to carbon. If I then move on to the hydrogen, I've got 4 hydrogens on the left-hand side, but only 2 on the right-hand side. So if I want to balance those, then I will need to put a 2 in front of the molecule of water. This means I don't have 1 molecule of water. I don't make 1 molecule of water. I actually make 2. This is what my 2H2O means. I don't change the subscript, only the coefficient. So now I've got the carbon balance and I have the hydrogen balance, and now I have to look at the oxygen. And I specifically left the oxygen towards the end because whichever number I put here, it won't matter because it will not affect all the other atoms I've balanced. So if I have a quick look at the left-hand side, I've got only 2 atoms of oxygen in the molecule O2. But if I look at the product side, the right-hand side, I see that I've got 2 atoms of oxygen here, plus another 2 from this molecule of water, but I have 2 of them. That makes 4 atoms of oxygen. So the way to have to balance this equation is to put a 2 in front of the molecule O2. And that's how the equation is balanced. If I now move to the next one, I generally tend to leave oxygen and hydrogen towards the end. So I tend to first balance any atom that is not hydrogen and oxygen. So following my rules, I look at the first atom that is not hydrogen or oxygen, and I spot that is the sulfur. And I'm going to be a bit lazy because I can see that I've got this SO4 here. And I've got it also here. I'm going to use them as if they were a unit. And if they are a unit, that's the anion sulfate. So I've got 1 unit of SO4 on the left and 1 on the right. You could have done them separately, the sulfur, the S first, and then the oxygen. I just chosen to do them together. You could do it separately if you prefer, if that makes, if it feels confusing for you. So that sulfur and that unit SO4 sulfate group is balanced because I have the same quantity on the right and on the left. If I go and find the other atom that is not hydrogen or oxygen, that's the atom of sodium. And I've got it here. And I've got 1 atom of sodium on the reagent side and 2 on the product side. So I need to put a 2 here, which means I've got this compound NaOH, which is sodium hydroxide, twice. And that means my SO4, my sulfate, is balanced, and my sodium, my Na, is also balanced. Now I tackle what I have left, the hydrogen and the oxygen. And it doesn't matter which one I choose, so I will start with the hydrogen because it's the first one on the left. I've got 2 atoms of hydrogen here, plus 2 atoms of hydrogen here. So 4 hydrogens in total on the reagent side. And when I go and look at the product side, I see that my molecule of water only has 2 hydrogens, so that's not enough. With 1 molecule of water is not enough to compensate all that hydrogen. I need 2 molecules of water. And that gives me my 4 hydrogens in the product side. And finally, I look at the oxygen, and hopefully it will be balanced, because if not, we will have a real problem. We have any other number, any other coefficient we add here will mess with our atoms already balanced. So I look at the oxygen, and again, I've got 2 atoms of oxygen. That 2 affects all that compound, sodium hydroxide, and I go to the product side and the molecule of water, and yes, I do have 2 atoms of oxygen here too. So that equation is balanced. All the hydrogen, sulfurs, oxygens, and sodium atoms are balanced, are the same number in the reagent and the product side. And now move to the final equation, and that one. I'll start with the first atom. The first atom is lead, Pb, and I can see that the reagent on the product side, I have 1 atom of lead in the reagent side, that's lead nitrate, and I have 1 in the product side. I then move to the nitrogen, and despite the fact that I have this bracket here, I'm not going to look at the NO3 as 1 unit, because when I go to the product side, I see that I don't have an NO3. In the case of the sulfate group, the SO4, I could spot it straight away as an SO4 in the product side. But here it doesn't appear as NO3. The nitrogen and the oxygen has parted ways. At least some of the oxygens have left the company of the nitrogen. So I need to tackle them separately. So I look first at the nitrogen, and I can see that parenthesis here, and the 2, and that means whatever is inside is double. So I don't have 1 atom of nitrogen on the left, I actually have 2. And I only have 1 atom of nitrogen on the right hand side, on the product side. So I need to put a 2 here to make sure that they are balanced. Okay, so now the lead is balanced, the Pb, the atom of lead is balanced, and the nitrogen is balanced, and I have to deal with the oxygen and see if it's balanced or if I have to do something about it. So I go back to the right-hand side, the left-hand side, and I look at that 2, that here, that is outside the bracket where the NO3, the nitrate group is. That means I've got 2 times 3, 6 atoms of oxygen in the reagent side. And then I look at the right-hand side, and I just count how many oxygens I have. So I've got 1 here, I've got 4 here, and I've got 2 here. That gives me 7 oxygens, which is inconvenient because I'm only expected to have 6, and well, this is to 7. However, you can do something which is have a fraction, which is have a fraction of the O2. So you don't have an O2, you only have half of it. And in some books, they will be happy if I look at now the number of atoms of oxygen I have on the right, I count and I've got 1 here, 4 here, that makes 5, and 1/2 of 2, which is 1, 6. That gives me the 6 atoms of oxygen that I need. And again, in some books you will see like that, and it is fine. It's more elegant not to leave a coefficient as a fraction, leave them as integer. So what I do is I multiply all the equation by 2 to get rid of that 2. So if I multiply all the equation, both the reagents and the products, by 2, I don't end up with lead nitrate. I've got 2 of lead nitrate. I don't have one time the compound lead oxide, lead 2 oxide to be precise. I've got 2. I multiply by 2 my 2NO2, nitrogen dioxide, and that gives me a 4NO2. And I multiply by 2 my 1/2 of the molecule of dioxygen, of the molecule of O2, and that gives me O2. And if I count again my number of oxygen, that gives me 3 times 2, 6 atoms, but now I've multiplied it by 2. That gives me 12 atoms of oxygen. And if I go to the right-hand side and I count 2 atoms of oxygen here, plus 4 times 2, 8, plus 2, gives me my 12 atoms of oxygen. So now the equation is balanced. It would be fine if you left it at the top, the 1/2 of O2. In most books, you will see how they double everything up, so to avoid having a fraction and to have only coefficients that are integers.